Hi, let's demystify AC circuit formulas. Now, this video is going to be very useful to students preparing for Nigerian students, especially preparing for Jamb, Utme, WAEC and NECO. Let's get right to it. Excuse me. Now, alternating current is also known as instantaneous current, and it is given by I equal to I naught sine omega t. Okay, omega t, where I naught represents the peak voltage, omega represents the angular frequency, and t of course is the time. Now omega or angular frequency is given by 2 pi f. Okay, excuse me, 2 pi f. So this formula can be rewritten as I equal to IO or I naught sine 2 pi ft. Okay, so the 2 pi f is the angular frequency, so you can also write it like this. So similarly, now note that the frequency f here represents the frequency. Okay, then the second formula is similar to the first, and it is for the instantaneous voltage or alternating voltage, and it is given by V equal to VO or V naught sine omega t, and similarly can be written as V equal to V naught sine 2 pi ft. Okay, where the V naught represents the peak voltage. All right, next formula. Okay, now one more thing I needed to, I forgot. This value here, omega t, okay, same as what you have here, is referred to as the phase angle. So if you're asked to calculate the phase angle is equal to omega t. Okay, and you have the phase angle. All right, number 3 is the formula that connects root mean square current and peak current. So we have that root mean square current is given by the peak current over square root of 2. Okay, some people would rather write it this way: 0.707 I naught. Okay, whichever you use, still the same answer. All right, now next formula is similar to this one, and it's the root mean square voltage. Root mean square voltage is also given by V naught over root of 2. Okay, similarly you can write it as 0.707 VO or V naught. Okay, now the next set of formulas that I'd want to look at, I'd want you to remember, is when you have a resistor connected in an AC circuit. Okay, now there are a few things to note there. First of all, we'll recall Ohm's law that V is equal to IR. V is equal to IR, and then R, of course, will be equal to V over I. Okay, now when you have a resistor in an AC circuit, you could use this and get everything you need. The V becomes the instantaneous voltage or the alternating voltage. The I becomes the instantaneous current or alternating current. All right, and this can also be connected to the root mean square. So this could also be root mean square over I root mean square. Okay, and this can also be equal to the peak voltage over the peak current. Okay, now just depending on what's the question, the information you have from the question, you can just play around with them. All right, so that's it for peak and root mean square. Sorry, that's for resistor. When you have a resistor connected in an AC circuit, that's what you have. And then there's one more thing I want you to note here. Usually just comes in objective questions. When you have a resistor in an AC circuit, the current and the voltage are always in phase. Okay, you can read up that. You can read that up. It's very important to note that too. So let's just focus on the formulas for now. Number 6, when you have a capacitor in an AC circuit, when you have a capacitor, so in this case I'll use the same Ohm's law. V is equal to I. Now a capacitor opposes the flow of alternating current, and that opposition to the flow of alternating current is referred to as the capacitive reactance, and it's given by XC. Okay, you see that it's replacing the R here, the resistor or resistance rather. Okay, so in this case, when you have a capacitor in a circuit, in an AC circuit, instead of using this, you use this. Now this has is given by 1 over 2 pi fc, 1 over 2 pi fc, where F is the frequency and C is the capacitance of the capacitor. Okay, so if you want to get the capacitive reactance, which is XC, this is what you use to get it, and then slot it back in here and get your V or whatever it is that you're looking for. All right, so that's for number 6. For number 7, can I put it here? Okay, let's use the next page. For number 7, when you have an inductor in an AC circuit, again we use Ohm's law. V will be equal to I. Then we have what we call the inductive reactance. Inductive reactance is the opposition to the flow of current offered by an inductor. Okay, it's called inductive reactance, and it is given by XL is given by 2 pi FL. Okay, where F is the frequency and L is the inductance of the inductor measured in Henrys. The unit is in Henrys, just capital H. All right, so that's for that. And then the next formula you would need to know is when you have these 3 components now that I just mentioned, or 3 elements, when you have them all together in a circuit, that is, I mean the resistor, the capacitor, and the inductor, when you have them in one circuit, in that case, you'll be referring to what we call, so from Ohm's law again, we have V is equal to I. Now, instead of writing R, the R will be replaced by the resistance offered by these 3 components. Okay, the resistor, the capacitor, and the inductor. And the resistance or the opposition to the flow of current offered by these components is referred to as impedance. Okay, that's the special name for it, impedance, and it's usually given by Z. Okay, so V is equal to IZ, and Z is given by the formula the square root of R squared plus XL, that's the inductive reactance, minus the capacitive reactance, all squared. Okay, so if you're looking for Z, this is what you would need to find your Z. Now, this formula can change depending on the question. Okay, it can be adjusted. That's why I prefer using this. Now, if the circuit contains only a resistor and an inductor, you wouldn't need this. You wouldn't need this XC. If the circuit contains a resistor and just a capacitor, you wouldn't need this. Okay, so the formula just changes. All right, so that's just how to play around with it. Okay, so remember, excuse me, remember this Z represents what is called the impedance. Okay, so if you're asked to calculate the impedance, that's what you would have. Okay, now also in a circuit that contains these three elements, resistor, inductor, and capacitor, the potential difference, okay, the effective or total potential difference across them, okay, you can write total potential difference or effective potential difference, is given by this formula V squared, V R squared, which is the voltage across the resistor plus, open bracket, the voltage across the inductor minus the voltage across the capacitor, all squared. Okay, with this formula you can get the total PD of the total PD across a circuit that contains this three. Sorry, I forgot to put this in. Okay, so it's the square root of this. Next formula is resonance frequency. Now, resonance frequency occurs when the capacitive reactance is equal to the inductive reactance. Okay, you can actually derive the formula using this, but for the sake of time, I'll just jump right to it. So, but just note that resonance frequency occurs when the capacitive reactance equals inductive reactance. Okay, and resonance frequency is given by this formula 1 over 2 pi square root of LC. Okay, this is the formula you use in finding the resonance frequency. And then the final formula I'd want to drop here that you would need is what we call the power factor. Okay, the power factor. So sometimes if you're asked, you could be asked to calculate the power factor. The power factor is simply given by cos theta equal to resistance over impedance. Okay, the whole of this is referred to as the power factor. Okay, now I'm going to be posting videos on different questions, different past questions solved. I'll solve them and explain. We're going to be using a lot of all these formulas to solve those questions. So just go through this again and get yourself familiarized with this. They are very easy to remember. Okay, and you'll be able to solve questions, any question at all from AC Circuit, especially for UTME, WAEC or NECO. All right, thank you, and please subscribe.